please find the Day 5 notes in your note packet. If you don't have a note packet, you can just follow along and write down any important information. So in this video, we are going to continue to talk about our trig functions, but we're going to use them a little bit differently today. So we know this whole unit we've been using trig ratios when we cannot use the Pythagorean theorem. We know trig ratios involve one angle and two sides of a right triangle. We use sine, cosine, and tangent to find those missing sides, right? What we've been doing, setting up our proportions and solving for a side length. But we also can use these trig ratios to help us find missing angles. But when we're finding missing angles, we have to use something a little bit different. So let's look at this first example here. And it's asking us to find the angle, find our angle x. So x is still our reference angle. And we're still going to go through the process and follow the same steps that we've been following. We're going to label our picture with O, H, and A. So I know in terms of my x, this 40 is my opposite side, 9 is my adjacent side. I know I'm finding angles, an angle at least. And because we have O and A, I know that that is going to be using my tangent function, TOA. So nothing so far has been different. I know I'm going to be taking the tangent of my angle, and that's going to be equal to my opposite side, which is 40, all over my adjacent side. Now, in order to solve, before, when my variable was in my fraction, I was able to cross multiply to get my answer. But here, my variable is kind of trapped in the parentheses. So no matter what, multiplying, dividing, anything like that, it's not going to get my x untrapped from inside my trig function. So this is where we're going to use what we call the inverses in order to find angles. So just like division is the inverse of multiplication, they undo each other. We have inverses for our trig functions, sine, cosine, and tangent, that undo each other. So it's very simple. The inverse of tangent is called inverse tangent, and we write it like this. Tangent to the negative first power. Again, you don't want to type that into your calculator. I'll show you how you do it right now. But the inverse tangent, we just use that little -1. And what happens is it takes the x and it puts the x now on the other side of the equal sign. So it kind of releases this x when you use this -1, when you use this inverse. And what also happens, we take our fraction, this 40 over 9, and that gets put inside of the parentheses when we do our inverse. So the inverse tangent of 40 over 9 is going to equal our x value. So let's look at how we type this into our calculators. So if you have a TI calculator, remember, make sure it says degree like it does up here at the top. And if you look on the calculator, it says sine, cosine, and tangent, those buttons that we've been using. But right above it in little, small, tiny writing, it says sine -1, cosine -1, tangent -1. So that's what we're going to use. We're going to have to type in second and then that button in order to get our inverse tangent. And then I can type in our 40 divided by 9 for this problem to get our final answer. If you don't have a TI, we know we all love to use Desmos, so let's take a look at that. So again, on Desmos, make sure you're in degree mode. And we see our sine, cosine, and tangent buttons. But in order to get those inverses, we have to hit function. Okay, when you hit function, you can see the keys change. Now we can see that inverse sine, inverse cosine, and inverse tangent. So we're going to hit inverse tangent. I'm going to go back to the main screen here. And again, I can type in my 40 divided by 9. And we get that same answer. Sorry, it's cut off on the screen. Maybe you can see it here. You get the same answer here when I type in that inverse tangent, that 77.3196. Okay, so again, on Desmos, you hit function, and you could see the 3 inverse tangent buttons there. Go back to the main to type in the numbers. So 77.3, for the most part, we're going to round our angle measures to the nearest degree. So this is going to be rounded up to 77 degrees. So once again, our final answer is just 77 degrees. So what we just discovered is that we can use inverse trig functions to find angles. Okay, when we're looking for angle measures, that's where we use inverse trig functions. And remember these few tips in order to help you get there. On the TI, remember you're hitting second and then either sine, or second and then cosine, or second and then tangent. And on Desmos, you hit the function option to choose the correct trig function in the inverse trig function. And then remember you have to click on main to get back to the numbers to be able to type in your actual fraction. So let's do a few more examples together. So every single trig function, every single trig problem, you start the same way. You look at your reference angle and you label your picture with your O, H, and A. I know my two sides are my opposite and adjacent side. I'm finding an angle, so that means I know I'm going to have to use inverses. Angles and inverses go together. Sides and cross multiplication go together. This is again an example of tangent, because again I'm using TOA. So I'm going to set up my equation, which is always the same. Tangent of our angle is going to be equal to the opposite side over the adjacent side. Now in order again to free up my x, I need to use my inverse tangent. So I'm going to take the inverse tangent. Remember, my x now is free, and I'm going to take my inverse tangent of 24 over 33. And once you know that this is my operation, you go to your calculator and you type this in. You should get 36.027, big long decimal. We're again going to round it to the nearest degree. So x is equal to 36 degrees. Number 2, proceed again in the same way. Here's my reference angle. 20 is the hypotenuse. 8 is the adjacent side since it's right next to it. I know I'm trying to find an angle, so again, that means we're going to use inverses. And because I have the adjacent and the hypotenuse, I know I'm going to be using cosine in this problem. So we're going to write the equation. And to free up my x, I have to use the inverse operation. So we're going to take the inverse cosine of 8 divided by 20, the adjacent over the hypotenuse. So x is going to be equal to 66.421, again rounding it to the nearest degree. That would just be 66 degrees. Go ahead and pause the video and try the next 2 examples. When you unpause the video in about 2 seconds, you will see number 3 and 4 completely finished for you. Were you careful in number 3? Number 3 had you find a side, so we did not need to use the inverses. The tangent of 48, in this one we're just cross multiplying. 12 times the tangent of 48 is equal to our answer. So I rounded my side to the nearest tenth. But number 4, we had to find an angle again. So using sine, in this case, I had to use inverse sine in order to free up my x and to get my angle measure. 39.5 rounds up to 40 degrees. Make sure you check your answers and write these 2 problems down. Pause the video if you need to write them down now. So anytime you need to find angles, you need to make sure you use the inverse trig functions. The last couple problems in our pink packet are going to be practice problems for you. Once you work on those problems, you can check your answer on the answer key that I have posted on our Canvas page. Good job today.